which one do you want to do most?
Recursion.
You want to do recursion the most? Okay. You write a solution of a problem as a series of steps where some of the steps are a smaller version of the original problem. Now you could pre-calculate them all up to this number and just
N is n minus 1 plus n minus 2.
Yes, and then you add them together, right?
Answer.
Yeah. Let's try to run this. Do you think this will work?
Well, it's not gonna know when to start.
Yeah, you're very sharp. You already knew that. See if that works. So there's this recursion error.
Because it keeps doing it, like it says like n minus 1 is like n minus 3 plus n minus 2, and it keeps doing it until it reaches infinity.
Let's try to see using the debugger to walk backwards in time. See if we can see what you're saying. We have we calculated all.
So the recursion depth is 990. So
yeah, so here it's trying to get the Fibonacci number at position negative 990.
Everything is none. Prev and answers are none.
Oh yeah, prev and answered are none. When you haven't assigned a value to the variable yet, it just shows up as none. I guess another thing is I could say go to the beginning here, and we're trying to get the fib of 7. But I can go inside of this function called here, and now it's trying to get fib of 6. And then I go inside it again. It's trying to get fib of 5 to go inside again. When it gets to 0, it still tries to do it for negative 1, and then negative 1 tries to do it for negative 2, negative 3, etc. It just keeps going forever. At some point, Python gives up because like that's too much. I can tell you're gonna keep infinitely going. That's the limit. You can't get any more. So that's infinite recursion.
You could do it until they reach like n equals 1.
Tell me what.
N is not less than 1.
Okay. If n is 1 or more. I mean, you write an if statement, it's a good thing to remind yourself to write else. Forces yourself to calculate what should happen if this one is not true.
Then stop.
Stop. But whoever called this function, they want an answer though. This guy is like n is 1 and I want the fib of 0. You kind of have to give them an answer. If you don't give them an answer, they're gonna try to do this calculation, and that's not gonna work out.
You could say if n equals 1, then there's no prev or prev.
Then you don't have to do this.
Yeah.
Yeah. Then so maybe we do this stuff in the else clause. But what do you want to do if n is 1?
You could like make a variable of the output.
Output. And what should it be?
Is 1.
And then just return it?
Yeah, return output. And then also if n equals 2.
Okay, else if n equals 2.
Then let's do the same thing.
Output is 1?
Yeah.
Yes, because for second number, the value is also 1. Yep. 13. Say a large number, say 100. That's gonna take a while, apparently.
10 hours later.
Do you have an idea why it takes so long to do this?
Because it has to go into each one until it reaches 1.
code, we're asking what's the fib of n equals 7. We called this fib n minus 1, and then it gave me the pref is 8. And then we call the next one, and it gave me the pref is 5. So I just added them together to get 13. But if you go in, yeah, you can see how it get the answer for this one. So this is how fib of 5 was calculated. But you realize that, well, fib of 6 also calculated fib of 5 here. So we have to redo this same thing twice, right? And there's actually a lot of this redo calculation. And that's actually one reason why this is kind of slow. So it's doing a lot of repetitive work. Like if you were to do it yourself, you would never do that, right? You already calculated the answer for that one. You're not gonna do it again the next time.
How do you make the Fibonacci thing faster?
Oh, okay. How can you make the Fibonacci thing faster? Alright. The way to make it fast is actually to not use recursion. There's another way, which is you make a table. So the way you do it without recursion, so what you do is you just start with the first two number. Next one is going to be A plus B. When A is here, B is here. This is the next one. I'm gonna call it N. And then I want the B to go to A and the N to go to B. So we've moved up. So the end result is I want A to be here and B to be here. And then we just do it again. Next is gonna be A plus B, and then move this over here, move this over here. But you want the B to go into A first before B's value gets clobbered by the N.
The first number is 1 and like the sixth number is 8. So how do you determine like which number is which?
You need to keep a counter. You need to keep a counter. Maybe call it C or something. If it's not true,
Brick.
now put this C less than target in here instead of the true. Put C less than target.
Can you do for I in range?
Yes, you can also do that for the range.
I range target N.
Yeah, what should you print?
Target is 1, then you pick A. If target is 2, you pick B. If target is 3, you pick N.
I think you're getting confused though.
I'm just gonna do 4. Oh, that's not.
Run it to the debugger.
Wait, so if you do
Just run it to the debugger. Do that,
if you do it
and then do the
wait, so 8 is the 5th.
you can just step
8
through
is
it.
the 6th number, so it should be A.
It should be A.
Yeah. Wait.
You don't have to do it in your head. The first time we do it, we have N equals 2. And then after the first time we have A. So we did this. Now we have this thing here. A and B are these two now after the first time. And then after the second time we did it, A and B are these two now. So we only had to do it twice, really. Yeah, we did it 2 extra times than we needed to do. If it's 5, how many times you do want to do it?
3.
If it's 6, how many times do you want to do it?
4.
If it's 7, how many times do you want to do it?
5.
Are you sure you want to divide by 2?
Then it's minus 2.
We're doing a lesson. So, hey. 3.
How do you do the table way?
Okay, let's do a table way. I'm gonna use a dictionary. So I'll say the table is a dictionary. And at the beginning of we're just gonna put 1 and 2 in the table. So I'm saying the answer of 1 is 1. The answer of 2 is 1. First.
Why do you use the brackets there and curly braces there?
So this one here, something colon something, we call that an entry. And the thing to the left of the colon, we call this a key. And then the thing to the right of the colon is a value. And the way you make a new entry is you put your dictionary here, and then you put your new key inside the brackets, and then you put the value on the right side of the equal sign. So if you do this, it's gonna look into tables that, hey, do I have an entry that matches with this key? If it finds the entry that matches with this key, it'll take the value and give it to you. So this guy ends up being the value. So if your key is 1, this whole thing is 1. If this key is 2, this whole thing is still 1, because both of them give you 1 here. If it's already in my table, don't bother doing any of this stuff. Just look up the table, and I know whatever the value is for this key, that's the answer.
So n is the key?
Yeah, we're using it as the key. So n is 7, it's not in the table. So it's gonna do, it's going to go in and try to do n equals 6. It's still not in the table. So it's gonna do n equals 5, n equals 4, n equals 3, and 2. 2 is actually in the table. So it just returns, so return value is 1, because it looked up this table for key.
And then it shows you the value.
Yeah, and now is the interesting stuff is happening here, because now we're gonna calculate the answer. 1 plus 1, the answer is 2. Now we're gonna stick the answer into the table, because we just figured out.
And then you go back into
look at
here.
look at the table here. Oh, not yet. We just entered the entry in the table, and we said we just calculated that fib of 3 is 2. So the table knows it now. For n equals 5, it doesn't have to calculate it again because it's already in the table. It's gonna return the value 5 directly from the table. Doesn't have to do all that recursion again. So it's fast. So we can probably do 100 now, and it'll probably work. Yeah, it did 100 okay, whereas the original one, yeah, it's taking a long time because it has to do so much recalculation.
Which one is faster? The key?
Is the table faster or the loop one faster?
Yeah.
I think the loop one is faster than the table one, but it has to use some memory. Whereas the loop...
that did it... Oh, that was 100. That was 100.
Too much recursion. Try 900. That's probably like a Python just has... Yeah! Try 999. Try 999.
That did it almost instantly.
I think Python's recursion limit is 1000. Yeah.
See,
1000 is...
The table is faster because if you do fib fast... And this is... Oh, okay, never mind. Last time it took longer to...
Fib fast is better than the table one because it doesn't have to remember a whole table of numbers. it just has to remember the last two. So it uses less memory.